Camouflage is important for prey animals. Most often their life depends on the use of this skill. Cuttlefish are well known for their highly adaptive camouflage, as you can see in these photos. Papers such as the ones featured on this slide explored how cuttlefish, who surprisingly enough are colourblind, use visual cues to determine body colouring and patterning for camouflage. Another part of camouflage is body posture, and Barbosa, Allen, Mathgar and Hanlon's paper, Cuttlefish use visual cues to determine arm posture for camouflage, explores to what extent cuttlefish body posture is influenced by visual cues. Cuttlefish belong to the class Cephalopoda, and this paper deals with the common European species, Sepia officinalis. 10 Sepia officinalis were placed in individual bisected teardrop-shaped tanks, which are surrounded by a black curtain to block out all external visual interferences. The 10 cuttlefish were tested on all 4 two-dimensional visual stimulus, which were horizontal stripes, or 0 degrees, oriented parallel to the animal's main body axis, 45-degree stripes, vertical stripes, or 90 degrees, oriented perpendicularly to the animal's main body axis, and of course a great control wall. Each of the 10 cuttlefish were tested on all 4 stimulus in a random order. Once the animal was seen to be settled and was ceased swimming and hovering, they were said to be acclimated and the picture was taken. As you can see from these photos, due to the rigid internal structures within a cuttlefish, any changes in body posture is limited to the arm movement. And as such, the angle measurement from each cuttlefish was taken from the horizontal axis to the arm closest to the background. As you can see from these photos, the cuttlefish were definitely influenced by visual cues, generally matching their arm to the degree of stripes behind them. This can be most notably seen in the grey control wall, where not a single cuttlefish raised their arm. Comparisons of all 3 stripe walls with the grey control wall prove that they were all significantly different, apart from the 45-degree stripe and the vertical or 90-degree stripe, where there are a few outliers. An interesting point is that the cuttlefish actually initiated camouflage as soon as that visual stimulus appeared. It just goes to show what a huge time advantage using visual cues for camouflage is over, for example, tactile cues, where the animal would have to waste vital time exploring the environment to determine their camouflage. In conclusion, Barbosa, Allen, Mathgar and Hanlon's paper found that the cuttlefish were influenced by the visual cues when determining their arm posture. This change in arm posture for camouflage is extremely important because the predator relies on a 3-dimensional specific image of their prey. A change in body posture, teamed with, for example, a change in colour or pattern, would alter the shape that the predator was looking for and could be the difference between life and death for the cuttlefish.